Okay, so plumbing with Node. So what did I mean by plumbing? So in the current world we live in, data is obviously the newest hot word, and data science is a term that gets thrown around quite a bit. It's a buzzword. It's one of the newest, hottest jobs on earth. But what people fail to remember is the fact that that data that data scientists use to train machine learning and models needs to come from somewhere, and it needs to be clean, and it needs to be ready. So this is where the term data engineering, extraction, transformation, and loading, and the three different types of statistics are, which is descriptive, prescriptive, and diagnostic statistics. So in terms of plumbing, we mean by cleaning the data, extracting it from various different sources, and being able to provide the data ready to do analytics and ready to do modeling and ready to train machine learning models on the basis of what different types of use cases has been set for the data scientists. So this is generally what's regarded as the plumber of the data world, which is why we said plumbing with Node.JS. The thing is, data engineering is a very peculiar field. And so, for example, if we have the space that we live in and the spaces that the data scientists live in, you are very much involved in both spaces, which is why a lot of the guys that work within the software engineering world get to cross paths with what data engineers do, because you tend to work with stuff like cloud stuff like Hadoop, data warehousing, and a lot of Oracle and a lot of data type stuff, and we get to build dashboards. But also remember, a lot of analytics that does indeed happen on the web. But a lot of memes go around, and that says that, you know, without cleaning of data, you know, you can't train a machine learning model. So the data scientists like to make the jokes that said 80% of their time goes into data cleaning. But this is actually where the profession of data engineering actually comes in, and actually the instrumentation and the reliability of the flow of how your data is cleaned and gleaned according to your business rules. What use cases has been set to the data scientist are highly coupled to what the data engineer does and the stages that the data needs to go through. And this is also where we get into the concept of what is called a data highway. So where your data goes through various different stages, and these different stages are value added. So for example, if you go through your first stage, it is where you would add your only remove certain null values or remove different values based on geographic location. For example, if you take Amazon, for example, or a company that is spread across multiple regions, they might have different ways of setting values for male and female, or currencies, or those types of things, which needs to be converted into one holistic view. So for example, if the head office is situated in America, all currencies across the world need to be converted into dollars, and everything needs to be converted into English, so that the heads of the company and the data scientists have data they understand and can work with in a uniform fashion. Traditional ETL is very structured and very rigid, and it is not very cloud friendly, if I can put it that way. So you need to stick to structured languages like C#, where you build SSIS and SSRS flows, or Starfish ETL, or IBM or Clio Cloud platforms. There are a lot of structured pipelines where you use these drag and drop interfaces. But the thing is, that is a whole different learning curve in itself, because that is, for example, for us in the software space, we need to move into that space where you can go and drag and drop pipelines, and you need a lot of different understanding of various different tasks. Whereas, for example, you want to create a dashboard fast and quick, you don't want to go through the hassles of doing that. And this is where the JavaScript developers tend to have an edge in most fields, because we have packages for almost anything. And we have packages like Charts.js, D3, and React High Charts, where we can create charts. But now the problem remains, where do we get data? And this is where we have a framework called CubeJs. It's one of very few, and it's a company that has tried to fully integrate the JavaScript Node.js environment into the web and provide a platform where you can extract data from different sources and provide different dimensions and simulate what is traditionally called within the analytics world, OLAP Cube, where you can segregate data on the basis of slices, dimensions, segments, which I will just explain on the documents now. It has a fully integrated schema generator. So for those that do not like running SQL or creating schemas within JS, you can create it on the playground, and it has support and plugins for all the leading front-end libraries and front-end chart libraries, which I will show you guys now. Right, so in terms of, let's start with the basics. So this is the concept of CubeJs. It provides the middleman between visualization and data sources, where you can ingest data from various different sources, aggregate, segregate, and also do pre-aggregations for faster performance using CubeJs. And it provides visualization and support for various different front-end frameworks like Vue, React, Angular, and HighCharts and D3. And you can then, if you want to scroll down a little bit, you can see there's support for various different charts and for React, Angular, Vue, Vanilla.js. And to go about this type of, so let me first show you guys the playground. So I have my server started. I have it hooked up to Postgre. And this is, for example, now, if you run it locally, you would see then you started with npm run dev. You can download the CLI to generate this whole thing for you. And if you open, for example, you would then, this is what you would be presented with your Docker Compose to deploy this to their cloud environment directly already. You would be greeted with a Node modules, and then you would also be greeted with your schemas, which you can now actually pre-populate. So for example, if I go into my playground again, and I go to the schema side, and I open one of my databases, which is connected to my database, and I, for example, decide to add all the tables and generate the schemas, you would notice inside of VS Code, I have multiple schemas now, and I have different measures and different dimensions for these various schemas and their different fields and their data sources, which in turn will then allow me, if I move over to the build side of things, for example, if I want to do a users count, and let's just do a plain aggregation first. Then you can check, here's your charts generated. If you don't particularly like a different chart, you can move and check what it would look like with rec charts, or for example, charts.js. And if you don't like React, you can check what it would simulate like in Vue or in vanilla JavaScript, which is not supported for this specific data. So it's very lenient, and you can also check from the API point of view how you would set up your query and the code for that specific query if you want to inject it into a specific component for the specific library that you're using for the specific framework. And if you really want to check the SQL out, there is also availability to check the SQL. And also, if you want to cache it on the database, you can then cache it and extract it from the cache with pre-aggregations and roll-ups, which is quite handy. So for example, now if you want to display data, let's say according to the users and according to the city, so user count, then you can extract it as a table. Or in our case, let's, for example, do a bar chart where we have the users count by Los Angeles, and we can add an extra aggregation, for example, by gender, and we can run it again. Then there's Mountain View by female, and also, as you can see, then it generates the code for you for that if you want to add that into one of your front ends, or if you want to do it via an API endpoint. So this allows you to utilize what is available around the CubeJS environment. And the beautiful part about this is it generates the schema and the queries for you, so you don't have to struggle with what normal ETL developers struggle with. And to show you some more examples about this and for this, so this is a HighCharts example, which is generated on the basis of American data, where you can drag your timelines and check data around. Really doing this. And here's another example of a dashboard which is basically just created on orders, where you can also add charts and different things. Here is a real-time application, so you can actually subscribe to different streams and have your dashboard listen and also give you event-based feedback on the basis of real-time streams. So it's a very handy tool for us as software engineers that do not want to dive into the world of ETL, but want ETL analytical capabilities on the web. And that is all from my side. I just want to highlight quickly, in terms of configuration, you can subscribe to multiple databases and extract from multiple databases at once using their individual drivers. So for example, if you have a database that is based on AWS, on Azure, or you have different like databases spread across local servers and some in the cloud, you can subscribe to them with their multi-tenancy and their configuration files. And then also you can do pre-aggregates, and you don't have to do cold start. So for example, if you have very large queries running, you can do pre-aggregations. If you, for example, check in the dashboard, you can do query was not accelerated with pre-aggregation, but you can accelerate it. So for example, if you want to alleviate certain time constraints due to the fact that certain queries are larger, you can pre-aggregate them. Then the CubeJs cloud allows for that, and it's all built into the whole environment and allows for full integration into all of the front-end frameworks that we use. And that is all from my side.